Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In chapter 4, we're going to learn about superposition theorem. So what is a superposition theorem? A superposition theorem is when you have any linear circuit. For example, the circuit we have here. When you have any element, the current through it or a voltage across it can be added together when you have only one independent source is turned on at one time. So for example, if you have on your left side here, there's three independent sources, right? So what should you do is, let's say we have three sources and independent sources on your left side here, and we put it into table form. So basically we have three steps here. There is, maybe I shall put into step first. Step 1, step 2, and then step 3. Okay. The idea is to turn on only one at a time. So when you have, maybe we start with 16 volt first. Turn on 16 volt and then turn off 4 amps and 12 volt. And step number 2, you have to turn on 4 amps and off the rest. And step number 3, to turn on only one, which is the 12 volt. Turn on this and turn off the rest. Okay, so what is our aim? The aim is, maybe we're going to find the current that I through 8 ohms there. So your aim here is to find I, okay, to find I, which have three independent sources in it. So basically we have three steps because of three independent sources. So you have maybe I1 plus I2 and plus I3. Because why? We only turn on one independent source at a time and we turn off the rest sources. So like this one, on this one, step number 1 plus step number 2, you turn on 4 amps, and plus step number 3, you turn on 12 volt. So individual of summation of only one turn on, you can have that I. Okay, this is your aim. So how to solve this problem? So how to turn off the voltage source and current source? In order to turn off the voltage source, maybe you still remember this. We have a voltage source in parallel, or you can put it this one as a series in a series with a resistor. So when you have this R small enough such that R is approaching 0. So what will happen to the voltage source? This one will becomes like the R here will turns like a through wire, right? A shorted path. So means that the current will keep on flowing through this and eventually will have a voltage equal to 0 because of the current keep on moving through this voltage source and discharge the energy through it. So we will have a eventually you will have a V equal to 0. Because why? Because if you apply voltage equal to IR, this R, because R is approaching 0, so it will have a voltage equal to 0. Okay, and what about a current source? When you have a current source, in order to give this to turn off the current source into 0, you need to make this load big enough such that it is approaching infinity, like a big wall of China. So that's basically no current will flowing through a big wall, right? So this pipe will becomes like an open circuit because current will not going through an open circuit like this. So eventually current will be equal to 0. So in order to turn off a current source, you can put replace a current source with a open circuit. Okay, you can replace a current source with an open circuit. And in order to turn off, this is how to turn off, right? And to turn off a voltage source, what you can do is replace this voltage source with a shorted path, short circuit. Okay, so how to solve this circuit? We know that we have 3 steps because of 3 independent sources. So you can draw the circuit. Step number 1, to turn on 16 volt, or maybe just put on 16 volt, and then you draw the figure. Okay, so turn off the current source. You can replace this with a open circuit because current source can be turned off by replacing it with a open circuit. And for voltage source, you can replace that with a shorted path. In a better way to draw this, you can maybe just put one line there. This is a 2 ohms here. Sorry, 2 ohms, and this is 8 ohms. So you have the one you are familiar with, right? The circuit, a linear circuit. Okay, now this I is a I1, this condition. Okay, second, you have a step number 2, which is to turn on the 4 amps. Okay, so to turn off this voltage source, you replace it with a short circuit here, and short circuit another one, 12 volt. And what is this I2? Because this is step number 2, which is from here, then you can write down this is as a I2. This is very important so that you do not calculate a wrong value. Okay, so step number 3, maybe I draw on the left side here. And step number 3, to turn on 12 volt, you can replace the voltage source here with a short circuit. Okay, and then the current source basically, yeah, turn off like this, but you don't need to draw it because it's already turned off. And then what is the I? I is actually basically this I3, right? So you write down this as a I3. Then how to solve it? So you can apply any method you learned before this, maybe from chapter 1, 2, and 3, and solve it. For step number 1, it is very straightforward. Just apply Ohm's law. You have voltage divided with the R. So this is 6 plus 2 plus 8. You have a 16 divided by 16. So this is 1 amps. Then for step number 2, I2 is equal to, you can actually reduce this circuit into because this is like yeah, all resistors, and this is 6 plus 8, so 14 ohms. This is, yeah, you can use what we call this, the current divider. Yes, so you're going to find I2 here. Since I2 is in the direction of the opposite of that current source, so you have a positive there, and you need the source. Source is 4 into what? Into the opposite of the resistor, which is 2, divided by 2 plus 14. So this is equal to 16 for half, 0.5 amps. Okay. And step number 3. Since the I3 here is in contradict of the passive sign convention of the source, so you're going to have a negative there, and voltage divided by resistor. And use your calculator, you're going to have a negative 0.75 here. And make sure you write the unit. And go back to your aim. Your aim is to find current, the total current, which is equal to I1 plus I2 plus I3, and this is 1 plus 0.5 plus minus 0.75, and the answer is 0.75 ampere. Okay, with that I think that's all, and thank you.